Number 14 with this challenge problem. Woohoo! Let's read carefully. Work backwards. Also, careful because the units are different. You'll have to convert one of the dimensions so it matches the others. A rectangular hat box, which in my mind looks like a rectangular prism, has a volume. Ooh, they give us kind of the end of they give us the answer kind of, and now we have to figure out one of these missing dimensions. It has 2 feet long dimension and an 18-inch wide dimension, and we're looking for the box's height. All right, so here is the dimension that's out of place. It's a unit that needs to be converted, so that's going to be 24 inches. And now we need our volume formula, because that's what we're dealing with, for a rectangular prism, which is either big BH or volume equals length times width times height. Remember, the length, width, height formula only works for rectangular prisms, not for triangular prisms. I think that's the LWH is going to suit us better here because it tells us, it kind of uses the language that fits that. It says length, it says wide, and it says height. So let's go with that. Now, this is a little different in that they give us the volume. So we're going to replace V with 5,184. We know that the length is now 24 inches. We're not going to put 2 feet. That would give us the wrong answer. 24 inches. And the width is 18 inches. And we're looking for that H. So 5,184 equals, we're going to simplify the 24 times 18. And that gives us 432. And we're going to have to try to find that H. Well, now we have to isolate that H by using inverse operations. So we divide by the 432, and we get that height would have to be 12 to give us the volume of 5,184. So that's B. So that's a challenging problem. We had to work backwards, and there was a little bit of unit conversion that we had to do, but I think you guys can handle it. Now, number 15, we're going for the volume of a triangular prism. Triangular prism because it has 2 matching triangular bases. If we need to find our formula here, formula, where's my formula sheet? Right here. Formula sheet, we're going to go up to prisms, and we're looking for volume, so we go over to the left here. I just like to use this highlighted formula there. You can see that down below it has a triangular prism formula with the 1/2 BH already replacing the big B, but I just kind of like to do my big B off to the side there. So I like to do volume equals big BH, and then off to the side I do big B. And I choose the right formula for this base, which is a triangle. So I need the area of a triangle, which is 1/2 base times height. I see the 4 and the 8 here meet at a right angle, so those are my 1/2 times 4 times 8. Those are my base and height. And I get 16. So with this, now I know that volume equals big B is 16. The height of the actual prism is 12 because it connects the 2 base shapes, the 2 triangular base shapes. And when I multiply that, I get 192, and it's volume, so it's going to be meters cubed. So let's see, 192, there it is, meters cubed. Now, number 16, we're dealing with volume again, but in this case it's a pyramid. So let's go over, not prisms, we got to look at pyramids. We're looking at the left side because it's volume, so it's volume equals 1/3 BH. Volume equals 1/3 big BH, and capital B is the area of the base. So we have this base, it's a rectangle, so I'm going to do BH. I got to do 6 times 6, and that gives me 36. I'm going to plug that in. 1/3 big B is now 36. The height of the actual pyramid is 8. And when I calculate that, I get 96. It's going to be inches cubed because we're doing volume, a 3-dimensional measurement. Number 17, getting to the end here. What is the surface area of the square pyramid? So now we're looking for pyramids again. I'm still in the pyramid section. I'm going to surface area. I got to use this formula. This is the one that always trips me up. surface area equals the area of the base plus 1/2 the perimeter of the base times the slant height. So I'm going to go off to the side and do my big B calculations and my big P calculations. So the area of the base, my base is a rectangle, actually more specifically a square, so I'm going to do base times height for that, and I get 19 times 19, which gives me an area of 361. And then I need the perimeter of the base, which is the length outside the outer boundary of that base. These are all plus signs, not multiplication symbols. There we go. Or you could do 4 times 19, and that gives me 76. Okay, now we're ready to substitute in for big B, which is 361 plus 1/2. The perimeter is 76, and the slant height is the height of the triangles that make up the lateral faces. So that's 12, and when we calculate all of that out, we get a grand total of 817. We're doing surface area, so that is going to be feet squared. So it is C. 18. Let's go. Surface area of a cube. A cube is just another type of rectangular prism. So we can use the surface area formula there, or we can find all the area of each of the faces and then just add them all up. You can decide, but I'm going to show you 2LW plus 2LH plus 2HW. That's right in your formula sheet. So I'm going to label these, but all of them are 11. So I'm just going to keep plugging in 11s. There it is. And each of these comes to 242 plus 242 plus 242. And that gives me a surface area total of 726. And we're going to do centimeters squared. Pumping these out. All right, so now we have area of these composite figures. So first we have to cut that into 2 separate shapes. I have a trapezoid and I have a rectangle. Now I'm going to go to my formula sheet. I'm going to go down to my 2-dimensional shapes at the bottom. I have my trapezoid over on the right, second one down, and I can either use rectangle or a parallelogram formula, but we already know that one, so I'm just checking on the trapezoid. All right, trapezoid. The area equals 1/2 the height times the quantity of B1 plus B2. And the area of the rectangle is just going to be BH. Now, when I'm looking at this trapezoid, I need the height of that trapezoid, and it's not given. I need this height here. That's a right angle to the 2 bases. Well, it's a vertical length, so I look at my other vertical lengths. I have this that's 8 and this that's 5. So it looks like this would have to be 8 minus 5, which would be 3. So now we have 1/2 times 3, and the bases of the trapezoid are always the parallel sides. So that's going to be 18 plus 12, and when I calculate that, it gives me a total of 45. And then let's do my rectangle there on the bottom. That's this here, and it has a length and width or base and height of 18 and 5. So when I multiply that, that comes to 90. So 45 plus 90, add those guys up, and I get 135. It's surface area, so it's going to be miles squared. Miles squared. Wow, that is an enormous shape there. Oh, hi, honey. All right, that's my little girl. She wanted to do some math. She just loves math. All right, number 20. We have the final problem of this review. Now, we have to slice this shape into our normal 2D shapes. So we have that half a circle, which we call a semicircle, and we have down on the bottom there a triangle. Now, you could just do circle formula, divide by 2, or there is at the bottom of the reference sheet a area of a semicircle formula. It plugs that 1/2 in there in front of pi r squared. So I'm going to use that. I'm going to say area of a semicircle is 1/2 pi r squared, and the area of a triangle is 1/2 BH. Now let's look at this closely. We're looking at the semicircle up here. It's going to be 1/2 times 3.14 times the radius. The 5 goes halfway across the semicircle, so that is the radius. So that's going to be 5 squared. That gives me a total of 39.25. And now for the area of the triangle, 1/2 times the base of that triangle actually goes all the way across the semicircle. So that's going to be 10, not 5. That could be a point that would trip you up. So the base is 10, and the height there that meets it at a right angle is 4. So that gives me a total of 20. We're going to add the 39.25 plus the 20 together and get 59.25, round to the nearest tenth. So the 5 tells the 2 to round up to 3. So we have 59.3 feet squared. Boom! Did it! You have reviewed officially, and now I wish you good luck on the upcoming test. If you take your time, if you are thorough, and you've studied, you will do great. All right, have a terrific day.